Okay, these are the 5-3 notes, and on these, we're going to find the intervals where a function is increasing or decreasing. So you're going to have your homework worksheet 5-3, which is due Wednesday. You're going to take the 5-1 quiz today, which is Tuesday, later on your own time. So the definition of an increasing function, a function f is increasing on an interval if any two numbers x1 and y1 in the interval are such that if x1 is less than x2, then the y value of x1 is less than the y value of x2. In other words, you got a point, and the point next to it is above it, that's increasing. Decreasing is if your x1 f of x1 is there, and it's greater than your f of x2. Your x2, f of x2, this is decreasing. So increasing left to right is going up, decreasing coming down. Hopefully we already know that. There's a test for an increasing and decreasing function, and these are the two biggies that you need in order to tell why or prove that something's increasing. It says let f be a function that is continuous on a closed interval. So we're including endpoints, and differentiable on the open interval. Again, the open interval is because you cannot do a derivative at an endpoint. Then it says if f prime of x, the derivative, is greater than 0, which means a positive, for all x in a and b, then f is increasing on the closed interval from a to b. And if f prime of x is less than 0, meaning a negative for all the x from a to b, then f is decreasing on the interval from a to b, including a and b. So if we look at this problem right here, the graph shown at the right is the derivative. So we're already dealing with this. We want to know where's the derivative, positive or negative, and we're going to use that graph to find the critical values. Well, from what we just talked about last class, or from 5-2, critical values occur where a derivative is 0, or you can't do a derivative. So this is a derivative, so there's a derivative everywhere. So there's a 0 here, a 0 here, and a 0 here. So my critical values, the critical values are x equals 0, 2, and 4, because that's where this is derivative is 0. State the intervals where f of x is increasing. Well, to be increasing, that means your derivative has to be greater than 0. So if you look right here, from here to here, f of x is above x, so we have positive here, it's below here, and positive again here. So we get to say that f is increasing on the interval. Oops, I need a bracket because we do brackets on these. If you look up here, increasing on the interval from 0 to 2 and 4 to infinity, because again, we're above x on these two things. So this is where it's increasing. And it says justify. So here's your justification. Because f prime of x is greater than, and you can also put equal to 0 on 0 to 2 and 4 to infinity. So that's that problem right there. Oh, we're also supposed to do decreasing. So let's go down here and say f is decreasing on the interval. Now, if you look here, it's negative here. So we would say on the interval from negative infinity. And again, you use parentheses on infinities because you can never get there. From negative infinity to 0 and 2 to 4. And this one is because f prime of x is less than 0, or you could put equal to, does not matter, on negative infinity to 0 and 2 to 4. Okay, so anybody got any questions on those? And again, you could put on those intervals instead of rewriting these. You could do the same thing and say on those intervals and fine. Going on to this next part, it says find the intervals for this function where the function is increasing, decreasing. So we want to find critical values first. So if you notice, there's no x's in denominator, so there's no places you can't do a derivative. It's continuous. So we need to find f prime of x. We want to find the critical values first. So we're going to get 3x squared minus, take 2 in front, the two 2's reduce, so it'd be minus 3x. So the critical numbers occur where 3x squared minus 3x equals 0. So I'm going to factor out a 3x. So my critical numbers occur when 3x equals 0 and when x minus 1 equals 0. So at x equals 0 and at x equals 1. Those are my critical numbers. So what I want to do is I want to be thinking about 0 and 1. And then I want to plug in numbers to find out where the derivative, remember we want the derivative greater than 0 and less than 0. So I want to plug a negative number in, a number between 0 and 1, a number greater than 1, into the derivative to find out where the derivative is greater than or equal to 0. So I'm going to plug it in right here. So if I plug a negative number in here, I get a negative right here. So that's a negative. And a negative minus a number, minus 1 is a negative. So negative times a negative means we're positive here. I'm going to plug in a half. So a half times 3 is a positive. A half minus 1 is a negative. So negative times positive is a negative. And then plugging in 2 is positive, positive, positive. So then we can say that f is increasing on negative infinity to 0 and 1 to infinity. I should have a bracket there. They'll take parentheses. Because f prime of x is greater than 0 on those intervals. And then we would say f is decreasing on 0 to 1 because f prime of x is less than 0 on that interval. Okay, so that's the second problem. Now, this thing at the bottom are the steps, and those are the steps that we just did. So when you look at this, it says f has to be guidelines for finding increasing, decreasing. F has to be continuous on the intervals. And first, we're going to find the critical numbers. So you're going to find where the derivative is 0 or where you cannot do a derivative, where the derivative does not exist. Then you have to determine f prime by picking test values between these. So like I might have picked -1 here, 0.5 here, and 2 here. So you just pick numbers and then you put your signs up there. And remember, this is f prime because we want to know where the derivative is greater than or not. And determine f prime by picking test values. Use the theorem of increasing, decreasing functions to determine the increases, decreases. So that's what we did over here. And then says replace the guideline above also works with the interval, replace the interval. Okay. So this is just saying sometimes you got infinity in there. Okay, so just a second here. All right, now down here at the bottom it talks about monotonic again, and I couldn't get that picture on there. So strictly monotonic, again, just means that the graph is increasing over the entire interval or decreasing over the entire interval. So it's kind of needed that you need to know what strictly monotonic means. Hope you have a good day. Good luck on your homework. And I will see you tomorrow.